Okay, good morning, everyone. Welcome to the fourth day of this Galileo Masterclass Brazil 2022. Today we have lectures from Brazilian researchers and professors from UFC, as we have in our technical program. And the first talk of today's will be given by Professor Eduardo Martins. Maybe you can load the slides of just to see the title of. Yes. Is it fine? Is it shared now? Okay. Okay, so Professor Eduardo Martins is the president of FUNSEMI, which is the Research Institute for Meteorology and Water Resources of the state of Ceará. And he's also a professor at UFC. And his talk will be on the use of remote sensing in water resource management. Eduardo received a bachelor's degree in civil engineering from the Federal University of Ceará in 1989 and master in water resources from the Hydraulics Research Institute at Federal University of Rio Grande do Sul in 93, and a PhD in civil and environmental engineering from the Cornell University in 2001. From 93 to 2010, he was a researcher on hydrology at FUNSEMI, which is the Research Institute of Meteorology and Water Resources, acting as its president since 2006. Since 2010, he was also hired as professor of the Federal University of Ceará. Dr. Martins' research has focused on the use of climate information on water allocation and planning, and in the past 15 years, his main focus of work is on climate variability and change in their impacts, drought-related issues like drought characterization, monitoring and forecasting, early warning systems, agriculture and hydrologic drought planning and policy. So, welcome, Professor Eduardo, and please, the floor is yours.
Okay, first of all, I would like to thank you for the invitation. It was quite a busy week, but I made it. And I'm trying to give a presentation more to not on research or on remote sensing, but on the motivation of doing research in remote sensing and how this can be used by a state like Ceará, okay, or Brazil. So I will talk a little bit about my institution. It's a state-level institution, but we have been working at the country level, supporting information on monitoring, on forecasting. The seasonal forecast of the country counts with our models as well. The drought monitoring system, we are one of the leading institutions that provides the monitoring. Today, we are expanding our drought monitoring map to the rest of the country. We start with Northeast, and then Southeast, South, Midwest, and now we are in the North region also doing the monitoring. And this demands a lot of products now in the North region based on remote sensing in order to improve the information drought monitoring for that region, okay? So this is just a teaser on how this area is so important for in making decisions and informing decisions for the country. So also we do have some role in monitoring, operational monitoring. We count with 2 weather radars, one X-band radar and one S-band radar for Ceará State. We also are acquiring a new one, X-band, to be installed in the east coast of Ceará. So the idea is to use this kind of information to prevent disaster related with extreme precipitation. So the major user here is the civil defense. But also the water agency would be interested in such products in order to decide on how to operate reservoirs to mitigate the impact of floods as well. And also we count with traditional methods for meteorological and agriculture and hydrological monitoring. So we have 550 rain gauges in the whole state. So this kind of information could be used to validate remote sensing-based information, and is also used to merge satellite-based products on rainfall to have a more reliable product and that could be used for applications, okay? And also we use a lot of satellites. No, it's not, okay. A lot of satellites for a range of applications, monitoring, data simulation for models, hydrological models mainly, experimental studies, environmental zoning, also do thematic maps that also are important information for application of hydrological models in the state. Okay, so I will try to do a comprehensive view of the applications that we are looking for at the state level, okay? And also at the country level in the context of our partnerships with federal agencies. So in terms of the applications, we mainly are focused on the infrastructure, and I will explain this a little bit later. Water management, both in the demand side and the supply side, and water quality monitoring and modeling as well, and precipitation monitoring. I will speak a little bit about this, and drought monitoring. I see a lot of areas here that the DETI could work with us on improving and also applying modern techniques on how to identify relationships of the variables that we're looking to these products and the variables of response, such as hydrological response or agricultural response as well. So in terms of infrastructure, the main concern that we have is the small dams, the non-monitory dams, and this is an issue that has some legal implications. So they impose some risk to society and other infrastructure. Just to give an idea, in a rainy year, we can have 18% of these dams broke. So this broken dam could impose risk to communities, to other infrastructures, and generate a lot of damage related to this breaking of dams. Also, they have major impacts in some areas of the state in the inflow of the bigger reservoirs, the ones that are dedicated, if you will, to allocate water to big irrigated districts, big cities, and so on, like Castanhão, Banabuyu, the biggest reservoirs that we have in the state. And also, it's important to do the licensing of new infrastructure. We will not allow new construction in areas that we have a higher density of this kind of infrastructure. We have a limit of inflow generation of that basin. So there is no point in building new infrastructure. So this information is also important on that. This is why the SWOT mission is quite important for us. This is why we are involved in this, because we want information on this small dam that otherwise we will not have if you don't have a sensor on automatic. So what we did approach this problem in two ways. One, just doing the water surface detection, and other one using high resolution images to detect the dams itself. So dams with the extension bigger than 20 meters And this was a visual interpretation. Why we were doing this at first place? It was very hard work, but the idea is to have this as a database that could be used later on to validate techniques, automatic techniques to do this kind of job. Okay, so we want to monitor new non-licensing infrastructure using automatic techniques, but in order to validate these techniques, we have to organize the whole database for regarding to this information. Okay, just to give an idea how many dams we have in Ceará, small dams larger than 20 meters of extension, 180,357 small dams. So we have the heat map over here. We have this very dark color here that represents a very high density, 6 dams per square kilometers. So we already have a lot of impacts on reservoirs like Banabuiú because of this high density that we have here of these small infrastructures. So this is why it's so important to look into this, generating extra information on the geometry of these dams, because the only thing that we know is they are located there. We did the water surface mapping every year around July, by the end of the season, the rain season, in order to determine the maximum area. But we don't have the information on volume. So we need to continue to extrapolate based on water maximum surface and other geomorphological characteristics of the basin, of hydrological basin of that reservoir, in order to estimate the volume or use a remote sensing based product that relies on automatic sensors. And this is what the mission of SWOT is about, that we are running this week with people from Kines. And this is just a second. This is just to show the process. It's visual interpretation, very basic stuff. But the importance of this is really to set up a database that could be used to validate other automated techniques in order to detect that in the other regions of the country. The Northeast is it's a semi-arid region, and because of that, we need this kind of product because we have a lot of small dams spread all over the place, and this has impact on hydrology and other water use as well in agriculture, because we have some inequality issues here. Those that can afford to build these dams, okay, there are farms that have 11, 20 dams, small dams, and the small farmer doesn't have any. And so when we are under drought, the water do not reach out the small farmer, and they cannot sustain production of irrigated crop during the season. And this is why we are also crossing this database with database on land ownership. We want to identify the areas that we need to act first in order to anticipate the impacts, because those that are most vulnerable need the assistance to get there first, regarding to the relative to the others. And we do this annual mapping of the water surface every year. The idea is to set up a time series of the area. And in the future, I hope we have some way we already have some estimates, but it's not that good, on the volumes as well. And so we're gonna have a series that we could have information of the retention of volume in a particular basin, how this impacts the inflows of the main reservoirs of the states, the monitored ones. This is just the map of the location of the dams, and we're crossing the products to see if they match. Of course they match, right? If you did it right, but we want to check. And this is another product, very basic one. The government of Ceará start a program called Water Match Program. The idea is to rely on the big reservoirs and use and locate treatment plants, water treatment plants close to it, close to them, and distribute water in pipes in order to reduce the losses that we have in the natural transportation in the rivers. So they want to do that. But what we did using remote sensing to identify all infrastructure that could supply water to small communities and cross with this. Why is that? Because we want to estimate the water consumption on those areas as well. So we want to have information on the big cities of the state, the districts, the most populated districts, but also in small communities, okay? And want to identify solutions that maybe could link this big infrastructure to supply, how to use this big infrastructure also to supply water when in the moments of crisis, in the moments of droughts. And so we are looking at both local and the regional when we talk about the reservoirs. We are talking about big reservoirs, we are talking about the region, right? It's a basin with 8,000 square kilometers, and we talk about local communities, 100 square kilometers, 50 square kilometers. The micro basins are very small. Okay, another thing that we did with, we are trying to automate this right now, is to identify the edifications of the state. We finished the state of Ceará, we only in rural areas, not the cities. Why is that? Because we want to have an idea of the water consumption for the state in a, how to say that, in a distributed way, in the small communities, in order to identify the water allocation that would be needed to supply water to all this population. This is a proxy. The idea would be to really have a good census, know who live, how many people live in each community, but this information is not available, okay? And the idea is to do this using the edification as a proxy, and we are validating this product in the areas that we are working on. Okay, so as I mentioned, the interference of the dams and the inflow. What we are generating here is the heat map for a particular basin. This is the Riacho do Sangue basin. And also other products. We see the density in micro basins, very small micro basins, that does impact the inflow to the monitoring reservoirs as well. And also, not only the inflows, but you look at the, how to say that, branches of the river that have most dams. And the idea is to identify those branches of river that maybe we need to decommission some of these dams because the obstruction to the flow is too high. And we want to prevent that. So, still in the context of small dams, now we are, FUNSEMI is now an early adopter of the SWOT mission products. And the idea is to have information that could help us on estimate the volumes of these small dams. The area that we are working on, and it's close to Piauí, is the area, how do you say, this area here, okay? Municipality of Crateús. We are now doing bathymetry in small dams in order to validate the products of the mission in the future, okay? And also we are going to do some bathymetry in this area for the next phase of the mission as well. So in terms of irrigated agriculture, what we are doing, basically what we are doing, using Sentinel in order to identify different types of crops, okay? We are not to identify the different types of crops, but just trying to differentiate temporary crops of the permanent crops. And this gives you an idea, if you cross this data with other database, the type of crops that they are growing in these areas, okay? So here the response, the spectral response that we have for permanent crops is like this, it's a flat line, okay? And for the seasonal crops, what we have is something like that. It varies throughout the year. So we did that for the whole Jaguaribe area, and now we are doing a survey trying to cross with those data in order to validate the types of crops that we have, okay? So in terms of, actually it would be better to call hydrological modeling, okay? Oops. Yeah, what we are doing is we are working with 3 hydrological models, trying to set up the models for the whole state. We have a German model called VASA. We have a Brazilian model called MGB, and an American model called SWAT. And the idea is to have information, estimation on inflow based not only in the monitoring of rainfall and evaporation, evapotranspiration, but also based on using the forecast, climate season forecast, in order to do hydrological forecast as well. So how remote sensing could help on this? What we are trying to do with one of the models is to do some assimilation of the water masks, the water surface, in order to improve the hydrological modeling in the simulation time. Okay, so we have almost real-time information on the water surface, and this is used to improve the information on the hydrological model. We're starting that in order to improve the hydrological modeling. In the background figure, you see the animation that shows how the change of this area, the Banabuyu area, that is mapped over here, is changing through time. This period of time from 2012 until 2019, it was very dry for this area, okay? And we do have, this is the Banabuyu reservoir. In the beginning, 2013, 14, there's very small water surface of the reservoir. It's the 3rd biggest reservoir of the state. As you can see how hard was the drought on this area as the drought increased its severity. 2014, 2015. Okay, so this is what we want to do, incorporate this information on small dams in close to real time in order to improve the hydrological modeling, to anticipate the inflows that we have for the monitoring reservoirs network. And based on that, we could derive operation rules for to these reservoirs in order to supply the demands that we have in the different basins of the countryside. Okay, and also we are using this kind of products to reach out to the users, providing some information to the water agency, to the water resource secretary, and other partners that work with us in this project. Well, regarding the water quality monitoring, I will stick to it. I will not talk a little bit, not much about modeling, but what we are doing is using Sentinel and testing different models in order to identify the water quality that we have in Castanhão, in Banabuyu, in the big reservoirs. And now we are testing how small the reservoirs could be by use of the Sentinel in order to estimate the water quality. Basically, we're trying to identify chlorophyll A, okay? And the idea is to do experiments on the field to get the spectral signatures in different moments in time and trying to relate that with the reflectance of different bands in the images that we have of Sentinel. Okay, we start working with this kind of products in 2012. By then was MODIS, the satellite that we use. And then we moved to Landsat Sentinel-2. And this is now we are trying to work with drones and hyperspectral cameras in order to have a specialized view of the water quality issues that we have in the reservoirs. And the good thing is water quality monitoring in the state is done for each reservoir each 3 months. And we have a lot of cases, a lot of events of peak of eutrophisation that the monitoring system didn't get it. And the reason was the frequency. Each 3 months, the event could occur between monitoring campaigns, right? And with this kind of technique, we could use in a frequency weekly or each 5 days or so. And if you combine different satellites, even more detailed frequency. So this is important to us in order to prevent the death of fish. We have fisheries that are fish farming that we are placing these reservoirs, water surface, and we could anticipate some of those events if you combine the monitoring information with the modeling. This is what we are trying to do right now. And we do not want to discontinue the systematic water quality monitoring. It still will have its value, right? Because we need to validate the models, the monitoring, and this is just a view of the surface, right? And we have a daily cycle of water quality inside of the reservoir. It's completely stratified around noon, and completely mixed by the end of the afternoon because of the wind peak. So we need to combine this kind of information, know the physics, the hydrodynamics of the reservoir in order to set up a monitoring system based on remote sensing that really are monitoring at the same time, maybe the stratified time around noon, and not mixing the variability in different points of the day, right? Because if you monitoring at noon is one condition, completely stratified. If you monitor by the end of the afternoon, the reservoir is completely mixed. So we don't want to mix the time of monitoring. It would be wise to establish a protocol. The time of monitoring, the best time of the satellite passing by the point of monitoring or the point of interest. And also how to incorporate this remote sensing information to with water quality modeling. So we want to assimilate this data in order to improve the modeling of water quality. This is something that is starting, is not easy, but we're trying to improve that. This combines the hydrological modeling effort as well. We are using SWAT that has a model for water quality parameters like phosphorus, nitrogen, and with this we could associate a couple with the hydraulic of the reservoir dynamics. We could associate with the change that we are seeing in the water quality monitoring as well. Okay. About precipitation monitoring, we have the conventional stuff. I will not talk about this. We are doing a lot about precipitation monitoring. I will not show the effort that we are doing with the National Space Agency of Brazil on the MERGE product that combines this kind of conventional monitoring of precipitation and the remote sensing base precipitation estimation. But we are looking for data, actually. And in order to get, to associate the information of the towers of cell phones, the noise of the towers of cell phones, actually, with the precipitation. And this is the kind of effort that Marielle Gosset from IRD, that is now expatriated from FUNSEMI, is trying to get the data in order to us to start working on this as well. We have some similar work done. Well, the Dutch was the first that I saw doing this kind of work. Okay, they have, it's basically a specialized information rainfall that could be very useful for civil defense in areas that maybe we don't have a radar, or we don't have, how to say, much conventional weather stations in order to get some information on rainfall. Regarding the drought monitoring, we are using all the effort as well on hydrological modeling in order to derive drought hydrological indicators. So the inflows, we run the series from the period of 81 until 2010, and this will be the reference. And after that, we normalize the information of inflows in periods of 3 months, 4 months, 12 months, 24 months, and derive normalized drought indicators based on inflows that were generated by the hydrological model. And this shows the results for Riacho do Sangue, okay? The evolution from 2000, I think, to 2012 until 2016 or so. Here you see the map that we have, the evolution of the map since 2014. That was the time that we initiate doing drought monitoring in a collaborative way with the institutions of the state and the union as well. And you can see how it expanded through time. This rely a lot on remote sensing derived products as well. In particular, in the areas that we have a low density of stations to do the conventional indicator computation, okay? And we are looking for other products as well. GRACE, we're looking GRACE-based products indicators. We have some people in Bonn that were working on that. We got interested, reach out to them and supply some data, but we lost contact. I hope soon we have some feedback on this, because this is some information that could be very useful, in particular in areas like Amazon. Amazonia, it would be really nice because we don't have much of a network there. So it would be very interesting to have more products on droughts based on remote sensing in that region. Well, that's it. I hope you guys enjoy, and I'm here available for questioning. Okay.
Thanks, Eduardo, for this very nice presentation. I have a couple of questions. Well, first I see you are using products from many different missions, from SWOT, MODIS, many different missions. How do you get these products, the products from the missions? Are they publicly free available, or you need to buy them through an agency? How does it work to get the data to make the models?
Generally, they are publicly available. Okay, Sentinel-2, we do have access almost in real time once the product is made available. But sometimes we got fun to do specific work to test the viability of a launch product, if you will. So a recent product that, whoa, this may be good. Let's put some funding here to test the product. And if it is, let's look for funding for use of an operational basis.
And the second question, you are talking a lot about the water in the field. Do you also investigate the quality of the water in the ocean near the coast, or this is another agency or another group?
Yeah, nope. We do not look into that. Our basic interest is continental waters. Okay, what we do relate to the oceans is to have information of the amount of inflow that reach out the sea, because this is information that the environmental sector wants to have. Okay.
Using this type of methodology, what's the index of water quality you can obtain? It's possible to obtain or
Sorry.
Using this type of monitoring, what's the index you can obtain about the water quality?
It's chlorophyll A
Only?
only.
Oh, okay.
Yeah. But we are testing the identification of certain bacteria that could impose risk to health, like cyanobacteria. And we are looking into that with a very precise image, but I don't know if we're going to have operational products on that. But we are looking into that with a partnership with IRD and the Institute of Research for the Development in France.
But if you use the normal bands of satellites, of these types of satellites, you can obtain the IKA, for example. No.
You can for sure obtain indicator that relates to eutrophication, that relates to the chlorophyll A, but the resolution of the bands will implicate a better product or not.
Yeah. Okay, thanks.
Welcome.
Okay.
So first of all, thank you for the nice presentation. My question is about the detection for the using mobile networks. As in Sierra, we have a lot of network deficiency, especially in remote areas. So how do you that? Like, could you please elaborate a little bit on this topic, like this precipitation on mobile using that?
The first thing is get the data. The companies do not like to share. Although we have some experiments in Africa that Verizon network they share completely the data set to the researchers there. But here I'm trying to do this through the government because we have a contract with one company, okay, and we want to add the terms in this contract of sharing data for this purpose of precipitation estimation.
But there, yeah, it's okay.
Ele quer que você fique em pé.
Oh, okay. 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 So the question is that, as I said, as you said, that mobile communication operators don't share this data with you. But my question is, in these remote areas where you want to go, how can you do that? Because there are no mobile towers actually there.
Yeah, I would like to have at least in the main cities of the state. If you can have a set of towers in the cities, the main cities of the state, it would be nice. So we could use this information for civil defense. Okay. For the whole state, it's not possible. The idea was not that.
I missed the last part because I had to go out. Eduardo, for the nice talk. It was very inspiring, very interesting to see the different activities that FUNSEM is doing to sense for different applications. My question is like, right, to
Yeah.
detect, to construct these heat maps where
Yeah.
you see, like, is there any I mean, are you also, or do you intend to use, or have you used it, data analysis techniques to, based on those, on the output of those images, to do some big data for prediction, for instance, of these things, problems?
This is the next step. What we are doing now, it's organizing the whole data set. We don't have a history of organization in terms of data sets. So all this information on infrastructure, on water quality, on all information that I showed here, we are organizing in order to provide not only to FUNSEM researchers, but also to the university. And maybe we have some students that are interested in looking this kind of machine learning, data mining techniques in order to derive new information for the state.
Because the prediction could be in space and time, because you have also the geographical dispersion of the hotspots, and this evolves with time, as you have shown in those years. And, this is a very fertile area for exploiting what you have already done, which is a very hard work, of course. Right?
The idea is exactly that: organize the data in order for us to work, but and the other partners to work on this as well. Yeah.
Clear. Thanks.
Okay, so is there any other question here in the room or in? Let me check. No questions on the Meet. So I really thank again our first speaker of today for this very interesting talk, very cross field, very complementary what we are seeing here in Galileo, in EGNOS, Copernicus, but also very, very applied science. So thank you very much. We will then have the coffee break, and in about 1 hour, we will have our next talk of today. So thank you.